This is our first lesson from Chapter 5 in the Grade 11 Applied Math course. The chapter is called Statistical Reasoning. We're going to start it the same way we started Chapter 4 by realizing that we missed a few things we need to define on the first page of the notes. So we'll use some of this empty space here on the front cover and we'll define a few things. Is my pen on? Yes, it is. Okay, perfect. Let's get a little bit of space on there and let's start defining stuff like, for example, we will start by defining what a population is. There's an everyday meaning to the word population that you're probably pretty familiar with. You'd say, okay, well, what's the population of a school? What's the population of a city or a country? It's generally how many people you're talking about. But to a statistician, population doesn't mean people, necessarily. Population is just the entire group that you want to draw conclusions about. So yeah, I might think about the population of the students here at FRC, and I might want to draw a conclusion about, on average, how tall is everybody? We'll get back to the word average in a minute. So I might try to find a height for every single student in the school, and there would be my numbers, my data. But think about actually doing that. By the way, if you want to try to get information about every single element of a population, whether that element is people, or to give another example, maybe I run a tire company and I need to know how good the tires are that are coming off the assembly line. So I want to test every single tire to make sure that it's going to be safe. Testing every single tire or asking every single student is what we would call a census. A census is a situation where you are testing or gathering data for every element. And again, an element of a population could be a person or a thing of a population. Now think about how tough that would actually be to do in most situations. Really, I'm going to take every single tire off my assembly line and run tests on it. The tests themselves might damage the tires. And think about trying to find every single student at FRC's height. Could you imagine? What about all the kids who aren't there that day? What about all the kids who don't really want you to measure their height? This is going to be difficult. So we probably aren't going to do a census of the entire population. We are instead going to take a sample of the population. Sample is a subset or a smaller group selected from the population. So my sample for FRC students might be, I will randomly draw the names of 5 students from every class and find their height. And if I draw a name of somebody who's in there, I'll just draw another name just to get the data I need. Hopefully that data will be pretty well representative of the entire population since I did it randomly. But of course it might not be. We'll be talking about stuff like that as we do this chapter. Is my sample representative of my entire population? If my sample had been just the basketball team, I have a feeling that's going to be somewhat biased in my data when it comes to the heights of the average student at FRC. Let's go back to a non-person type situation. Again, let's think about my imaginary tire company that I'm running. How about I just take every 10th tire off the assembly line and run it through tests? See if the tread is correct on it, apply a hammer and nail to it to see how many pounds of pressure it takes to poke a hole in it. Again, this is sampling. And if you're actually testing samples, you're probably doing what's called a survey, right? I have surveyed every 5th student in a class. I have surveyed every 10th tire on my assembly line. So that is, again, gathering data, I should say from here, not for, from my sample. And sometimes we just call this selected sampling as well, but survey is a good word too. Okay, so there's the first 4 words. The next words that I want to get you to think about is, well, what are we here for? Oh yeah, statistic. What is a statistic? It's funny, sometimes I ask that before I even start this lesson. So we're studying statistics. Oh yeah, cool, did that. Remember that from grade 8. What's a statistic? And I usually get a blank stare. I don't know, it's a number. It's a piece of data. Here's the technical definition of a statistic to a mathematician. It is a numerical characteristic of a sample. Again, sample being something that's taken from a population. So numerical characteristics are statistics. And notice that the word is sample. So if you're telling me I actually did a survey of every student at FRC and find all their heights and then figure out what the average height is or what the tallest student is or what's the average height of every single one of the 1,400 and something students here at FRC, that's not a statistic. Actually, technically it's not. It would be what's called a parameter. Parameter is the word we use for a numerical characteristic of an entire population. So technically speaking, the average height of every student, or the average height of the school, if I did a census of it, would actually be what's called a parameter of the school. The tallest kid in the entire population is a parameter of the school. Having said that, here in grade 11 statistics, we don't use the word parameter very much, and some of our questions will involve populations and not samples, and we'll still probably call it statistics. We're still calling the unit statistics, and let's face it, when I say we're doing statistical reasoning, most of you have some idea what I'm talking about. If I had said parametrical reasoning, you'd have all looked at me with a blank stare, even though that's what you call it when you're talking about a whole population. Now, speaking of things that you probably do already know, the next page has some things that I'll bet are fairly familiar. First up, what is a measure of central tendency? Well, measures of central tendency are values that represent I'm going to put this in quotes because it can mean more than one thing, the middle of a set of data, which is a set of numbers. Okay? And the 3 measures of central tendency are the next 3 the next 3 definitions on the list. Mean, median, and mode. The 3 M's. We're going to say measure of central tendency so often that I think I want to abbreviate it. From now on, I'm just going to call that MOCT, mocked, just to save some writing, if you're okay with that. And I'll use it right now. Most of you probably remember what your mean is. Some of you will probably go, oh yeah, that's what we call average. Let's talk about that. First, let's define it. A mean is a measure of central tendency found by dividing the sum of a set of data by the number of data points. Most people look at that and go, oh yeah, that's what I said, average. Add them all up and divide by the number of things. The problem with calling that an average, though, instead of a mean, although I have heard people call it the mean average, is that there are other ways to find the average of a set of data. We'll get to those in a second. You can probably guess. It's the next two things, median and mode. But before we leave mean, this is math, we should have a formula for it. Here is the formula. The formula is add up all of the data points, we'll call those data points x's, and divide by the number of data points. N is going to be number of data points. You're probably looking at that going, what the heck is that wacky looking sideways W? It's actually the Greek letter sigma, and it just means find the sum. Find the sum of x data points where n is the number of data points. So what does this equal? This equals the mean. The symbol mathematically for a mean of a set of data is x bar. We actually call it x bar. And that is for a sample. Just like statistics themselves are for samples. They're called parameters when you're doing a population. And if you are doing the mean of a population, you're not supposed to use x bar. You're supposed to use another Greek letter. It's like a U with a tail on it. It's the Greek letter mu. You actually pronounce that mu, like a kitten. And that is for the mean of a population. It's the same thing. You still add them up and divide by the number of things, but you just use a different symbol for it. We're mostly dealing with statistics. Most of the data we deal with is sample data, so we're going to use x bar more often than mu. But they'll both pop up. Okay, like I said, we don't always consider the word average properly. Average doesn't necessarily mean that you did a mean. Haha, pun intended. It doesn't mean for sure that you added things up and divided by the number of things. Like, for example, let's say I have a professional sports team where there is one superstar player. He makes $10 million. Everyone else on the team makes $100,000. If I were to add up all their salaries and divide by the number of players, notice that that one super rich contract means that the average player makes millions of dollars. But that's not true if you really want to think about average as being the measure of central tendency. A better measure would be, why don't we just list all the players in a row and pick whoever's in the middle and say that's the average salary. And that would be a median average. A median is a measure of central tendency found by ordering the data, pen issues, the data set from smallest to largest and selecting the middle value. I'm sure some of you probably remember back in grade 8 when you first learned how to do a median that you have to kind of think about, okay, so what do we do if there's an even number of data points? Like, for example, suppose I had 4 data points. What's in the middle of 4 things? Well, some of you probably remember, oh yeah, I remember what to do. You take the second and third thing, add them up and divide by 2. So we will do that on some of our examples here. But yeah, median is just the number in the middle. If you have an even number of data points, the middle is the mean of the 2 middle data points. So for example, let's just do 2 examples. Example, if I have the data 1, 2, 3, 4, oh, what's our symbol? Our symbol here is x tilde. So I'll say that, x tilde. That's how you spell tilde, I think, T-I-L-D-E. Some people call it squiggle X. If you want to call it squiggle X, that's fine by me. I have seen some places that use capital letter M for median, but I don't want to do that. I like X squiggle. I think that's what our textbook uses. So 1, 2, 3, 4, what's the median? Well, actually, why don't I do an easier one first? 1, 2, 3, 4, 5, what's the median? Clearly, the number in the middle is 3. So in this data set, X tilde is 3. But for example 2, What if I have the data set 1, 2, 3, 4, 5, 6? Now what's in the middle? Well, the middle is somewhere between 3 and 4. So my x tilde would be 3 plus 4 divided by 2, which is 3.5. Oops, come back here. 3.5. So let me put that a little bit better into focus for you. There we go. So there's median. Hopefully you guys all remember that kind of stuff from grade 8. Then the third measure of central tendency is mode. A measure of central tendency found by determining the most frequently occurring data value. So if I have the data 1, 2, 2, 3, my mode is 2, because 2 happens more often than the 1 and the 3. The symbol we usually use for this is a capital M with a little O beside it. So for this data set, my mode is 2. What's my mode for this data set? Suppose I have 1, 1, 2, 2, 3. Do you remember what you did from grade 8 when that happened? You'd say, all right, fine, I have 2 modes. We have bimodal data. 1's a mode, 2's a mode. If no number happens more often than any other number, you can say you don't have a mode. Not every data set has a mode. Some data sets are unique for every data point. Can you have mode as an average? Sure, I'll give you a good example. Suppose I ran a shoe store and somebody asked me, what's the average size shoe that you sell? Would it make any sense to line up all of the shoe sizes I sell and pick the one in the middle for a median? Would it make sense to add up all of the shoe sizes and divide by the number of shoes I sold for a mean? I make it size 7.3. I don't even have a 7.3. My sizes are in halves. So I would probably say, well, the average shoe that I sell size-wise is just the one I sell the most of. The mode. I have no idea what the average shoe size is. Just making that up as an example. All right. Couple more pieces of statistical type, what's the word I'm looking for? Vocabulary, I guess, that we're going to be using over and over and over again in this course. How about range? This is not a measure of central tendency because it's the, I'll define it first. It is the difference between largest and smallest data points. So biggest number minus smallest number, that's your range. So that doesn't tell us where the middle is. It's not a measure of central tendency. It's a measure of how spread out data is. The word for that is dispersion. It tells you how dispersed your data is. So dispersion, how spread out your data is. And let's take an example again. So say for my example is I have the data set 1, 2, 3, 4. Then my range, capital R, is just 4 minus 1, which would be 3. Biggest number minus smallest number. Okay, so hopefully you remember that one from grade 8. I'll give you a sec to catch up to me. While I think about this one, what's an outlier? Well, an outlier is a data point with a value significantly larger or smaller than the rest of the data. So again, think about my example of the team of hockey players who, for example, The first guy makes $10,000 a year. I'll just say 10K. The second person makes $15,000 a year. The third player makes maybe $12,000 a year. And the fourth player, we'll just do one line. There are 6 players on the ice in a line of hockey if you include the goalie. So we have a $10,000 player, a $15,000 player, a $12,000 player, an $11,000 a year player, and then we have another $10,000 a year player, so that would be our mode. And then we have our superstar who makes $10 million a year. Clearly, this person is an outlier. Statistically, far, far different in value than the rest of the team. So including him in a mean average is going to do what's called skew the average. It would be far too big to be a good measure of central tendency if I just took the mean of all those numbers. All right, so there's the vocabulary kind of dealt with. Let's start actually dealing with some data. The first example we have is done for us using a online calculator that we tried in class the other day to make sure we could get it to work on our phones, called Calculator Soup. And here it is. Here's the set of data points. And okay, I'm going to show you one more time how to get to this. So if you open up the blog on your phones, I'll give you kind of a sec. I'll do this slowly so you can keep up to me. Open up my blog. Go to your class, which, the fastest way is to just go on the right here. There's your class. And if you take a look, I already have today's lesson kind of updated on the blog here. And here it is. This one here at Calculator Soup. Open that, and there's our set of data. Now, you can use your phone to just, with your finger, enter the data points. You can just bring up the number tab and enter in the data. We'll try entering the data the way it is here in our book. 5, then 32, then 34. But many of you are going to find there's some shortcuts here. I did this with a student the other day. It did work. He even managed to get it to work on my Android phone. I believe this works on Windows, or on iPhones as well. If you actually go to the notes on the blog, let me go back to the blog here. I'll just open the blog again. Blog. If you actually go to the notes on the blog and the actual note booklet, and say that you opened the note booklet from the blog and either downloaded it or opened it in Word. I guess you'd have to download it and open it in Word. So if you open this in Word, so I'll open it in Word over here on my other screen and just bring it over for you. You can cut and paste into Calculator Soup. So I'll go to the page that we're on here and I'll say, okay, yeah, there's the data numbers. I'll cut and paste that. Some of you can do this with your phone. I'll just Control-C and then go back to my Calculator Soup page and paste them, and there they are. That saves me having to type them in. Isn't that nice? And then once I've got my data in there, whether you had to type it or you found a nice shortcut way to cut and paste it, all you do is first of all make sure we're talking about a sample, and you hit Calculate, and it will do the work for you. It will add up all these numbers and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and divide by 13. And when it does that, it gets a mean, which again, there's our symbol X bar, of 33.923. Okay, so there's our mean. Then it'll find the median for us, which, as you can see, these are in order. So there's 13 things. The middle number is the 7th thing. 1, 2, 3, 4, 5, 6, 7. So there it is. 36 is the middle. So that's the median. And it finds the mode, which is, there it is, 36. And then there's some other stuff that we're going to talk about later on in the chapter. For now, mean, median, mode. Range, if we need it, 37. No problems. Okay, if you would like to do this on Desmos, you can go back to the blog if you want to and open up Desmos. Some of you have already kind of told to put that on your phone as an app. So Desmos, as you can see, is going to basically be like a grapher, but it still handles data pretty well. Now I'm going to still have this as something I don't need to type in, but you have to tell, if you're going to put data into Desmos, you have to tell Desmos, hey, this is a set of data. So you call it something. I'll just call this data set A, and I'll just use letter A. And if you're wondering, oh yeah, I'm typing on a keyboard, of course, you can bring this up and type in, again, go to the keyboard and go to capital A, and then go back to the numbers and go equals. And then what you're going to have is, I need to make this a bit bigger, don't I? Nope, smaller, bigger. Okay, I don't know why it's not the full screen, but all right. Anyway, A equals, there's the equals button right there. And then you can go to, back to this screen here and pick this square bracket. Now it knows, oh, you would like a list of data points. And I still have this on my, I probably have to do it as Control V. I probably have this on my clipboard. Yeah, there it is. And there's the 13 elements of my list. And now, if I would like to do the statistics, find the statistics that we found on Calculator Soup, I have two ways I can do it. I can actually type in the word mean, and as soon as I do that and open a bracket, it knows, aha, he wants the mean. But I have to tell it from which set of data, so I have to say from A. And there's that same number. If you don't like doing it that way, follow along. You can do it like this. Go to our keyboard and go to functions. Go to statistics functions and type mean. That's probably less work than trying to type on the keyboard on your phone. And then again, you're gonna, this part, however, you still have to type, you still want the mean of set A. And then you can find the median of set A. Same trick. Go to functions, go to median of set A, 36. Same thing we got before. Now, unfortunately, take a look in the functions. For whatever reason, they've decided when they programmed Desmos to not do a mode, which is a bit of a drag. It's like, oh, there's no way I can do mode. Well, we have a way around that. For a small data set like this, I can just look at it. If I click on the list again at 13 elements, it will give me the whole thing, and I can hopefully look at it at, oh, it's actually not letting me look at the whole thing. Okay, fine, I can just scroll through it and find which one happens the most. But that might not be easy if there's dozens of numbers or maybe even hundreds of numbers in this list. So if I want to find the one that happens the most, there is a trick I can use. I can make what's called a dot plot. I'm going to go back to my statistics functions, and there is a list of visualizations, and I'm going to visualize a dot plot for data set A, and then click on this little zoom fit here, and look at that. See this number here? That's the one that happens the most, and it's 36. So there's my mode. I know my mode's 36. Kind of cheating, I know. I kind of wish Desmos had a mode programmed into it, but it doesn't, so the dot plot does the trick anytime I need it. Okay, our turn to try a new piece of data. So first thing I'll do is I'll go back to my, well, first we'll go back to the notes and actually see what the next set of data is. So here it is. I'm going to call this example 1. It's kind of done for us. And we're going to skip this page because nobody in class told me that they use a TI calculator, so we're not going to deal with that. So here is our data for the next set. The following is a set of 40 scores achieved by students on an examination. Okay, how are we going to deal with this? Let's do Calculator Soup first. So again, if I want to try the trick where I cut and paste, I should go maybe to the Windows or Word file and Control C, and then go back to my Calculator Soup. Just reset the page. Yeah. Oh wait, didn't like that. Continue. Sorry, the Calculator Soup does have ads. Oh, there's a clear button. I'll just use the clear button. There we go. Hit the clear button, make sure you're on sample, and then just paste my data, and it will figure it out. If you hit calculate, I know it's like, oh, but all the spacing, it didn't know what to do with it. It'll figure it out. See, there you go. Not only did it figure it out, but notice that it actually took a second and put it in order for us too. It sorted it for us. Isn't that nice? And now we can see from our data set that we have ourselves a Mean, median, mode, and range. So let's go back to the notes and put those on there. Thanks to Calculator Soup, our mean is, let's use our fancy new symbols, X bar. Oh, now I might have this argument. Wait a minute, 40 scores achieved by students. Maybe that's the whole school. Maybe it's a tiny little town and there's only 40 students. Wouldn't you call that a population? Unless you actually in the question take the time to tell me that this is a population and not a sample, I'm going to assume it's a sample. So I'm going to use X bar, not mu. And if we look back, it was 57.03. I'll use 2 decimal places. And then X tilde. Again, you want to remember that that's mean. If you already remember that, don't write that down. This one's median. X tilde is, what was the X tilde again? 62? That's how good my memory is. I was just looking at it and I don't remember. There we go. Yes, median was 62. Just checking. And of course, mode, again, mode, is going to be 65. I remember that one, and I could kind of see it when I typed it. Let's see if we'd have got the same answer using Desmos. So let's try it again with Desmos. Now Desmos actually I think will not work. I'm going to give it a try. I haven't tried it in a while. So I'm going to open up a new Desmos page here. Desmos. And I'm going to say again, set A is equal to, open my square bracket E, and then I'm going to try Control V. Oh! It didn't work. It assumed all the spacing that I copied was some sort of weird data chart. I don't want that. So nope, sorry. Either one of two things. You're either going to sit there and type in all of those data points from this page, or you're going to say, isn't Mr. K the nicest teacher in the whole world? Because let's go to the blog and look what he did for us. Go to the blog, where's my blog? He actually said, to save you some typing during the lesson, here's the Desmos file with the data for example 2. So to save you sitting there during the lesson and doing a whole bunch of typing, there it is. So if you go to that link, I'll give you a sec to get there. I've already got all of the numbers for you. Isn't that nice of me? Mainly, I just don't want to deal with people going, I got the different answer for mean than you. Yeah, that's because you typed in one data set out of 40 wrong or something silly like that. Okay, so I'll give you a sec to find that. It's on the blog. And okay, hopefully everybody's here now. And let's just see if we get the same answer that we got from Calculator Soup. What's the mean of data set A? 57.03. It rounds to the same number. What is the, oops, didn't mean to do that. What is the median of data set A? 62. And okay, again, how do we find the mode? Well, oh, and we need to find the range. You know what? I don't think there's a range in here either, is there? Let's go to functions. I don't see a range. No, doesn't have a range. Well, rats. How are we going to find a range? Well, I got an idea for you. You know what we can do with this data? We can sort it. Go under operations and sort data set A, and it'll put it nicely in order for us. And then it's like, yeah, but I can't see them all because there's 40 of them. Just click 40 element list and there it'll put them all. And from here I could also see my mode, right? I can go, okay, which one happens the most? Well, 41 happens 3 times, 4 times. Oh yeah, but 65 happens 1, 2, 3, 4, 5, 6 times. So yeah, 65 is my mode, and I can find my range by going 97 minus 16. And that would give me the same answer that I got for range on Calculator Soup, which I actually haven't written down yet. What was it again? My range was 81. So let's go back to our notes here and fill that in. My range, capital R for range, is 81. And there we go. Found the mean, median, mode, range. for the data. Are there any outliers? Well, it's hard to tell just looking at it as a jumble of data like that. Let's go back to Desmos and look at it in order. Desmos. Okay, well, yes. I might, this is one, I shouldn't have picked this as a first example maybe. This is one where I could have a good argument kind of both ways. Certainly the person with 97 is not a high outlier because there's other people in the 90s. But the people in the teens, woof. There might be people going, yeah, but there's people in the 20s, that's not much higher than the teens. But man, if I have a class where I've got a couple people in the teens, I might call those outliers compared to the rest of my data. I might even call the people in the low 20s outliers as well. But I might also argue that, you know what, the data's kind of evenly spread out. There's a few people in the really low end who were clearly not doing well in the course, and there were some people who absolutely rocked it and got 90s. I don't know if I even have any outliers. I might argue that I kind of don't have outliers. There are some things in statistics, unlike other branches of math, that are kind of subjective, and opinion kind of has a place here. I might argue that there's not really any outliers. Nah, not really. But somebody else might argue, are you kidding me? 16 is a heck of a low mark compared to everybody else. That's my outlier. I'd accept that argument. But I'm going to make this argument. I'm going to say I don't really have an outlier. I have some stories to tell you about interesting places in the history of statistics and data where outliers really, really were important to the study of certainly in science. We'll get to those later on next week. Anyway, anybody have any questions for this, please make sure to message me on Edsby and make sure that you take the time to try this next example yourself. Okay, so I'm not going to go through all of how to do this again. You can go back and do it for yourself, but let's take a look at the situation together, and then I'll leave you with this one to try. And on our first class back, we'll make sure we all got the same answers. Paulo needs to buy a new car battery for his car. He is trying to decide between two different brands. Both brands are the same price. He obtains data for the lifespan in years of 30 batteries for each brand. So perhaps some magazine article in an automotive magazine did a survey where they tested 30 batteries from each of these two brands, and that's how many years they got out of them. This kind of data is usually pretty easy to find online. So which one would you say is better? Well, what we'll do is we'll compare the mean, median, mode, and range. Once again, you can get this on Calculator Soup by going to the data and highlighting it. And ooh, this one might be a little harder. This one, for those of you using your phone, you might have to take like a snapshot of it because this is just a picture. I don't know. I'm going to try this. If I do a... Oh no, you know what? I'm not going to try this because it might mess up my recording. I was going to say I could take a snip of this. Some of you might be able to use photo and take a photo of just this section and then go to your Calculator Soup and just, again, we'll clear all that and then just paste it in there. Otherwise, you're actually going to have to sit there and type in 5.1, comma, 6.2, comma, and oh yes, this will take you a while. So we won't sit here and do this on this video. It'll be an hour-long video. So you can either try to cut and paste it yourself, explore the technology in front of you, explore whether or not your phone will let you do that, or just sit down, roll up your sleeves, and type in all the numbers, and that's your brand X. For Desmos, for this one, and again, I think you should try both. For Desmos, once again, I put the data into a file for you to save you some typing. So open that one from the blog, and there's X and there's Y. So if I want to find the mean, make sure you've realized that you have to use mean for X and mean for Y. So if I go, I'd like to know the mean of data value X, and there it'll give me for that 30 element list. Yeah, so there's the first answer for you. You can find the rest, and we will correct those together first thing Wednesday morning. Extra long weekend. Woohoo! Also, if you take a look at the blog, I would also like you to do page 211, 1 to 3. So technically there's 4 questions for homework. You have the rest of this class to try them. For that last example I left you with, you should use both Desmos and Calculator Soup. Get used to them. But I'm going to say that for this homework from the textbook, I would use Desmos for number 1 and number 3, and I'd use Calculator Soup for number 2. All right, I will end the video there. Thank you very much for paying attention, and good luck with your tech, everybody. Have a good weekend.